Good afternoon, everyone, and welcome to this the first of a new series of Resilience Engineering Association webinars. It's 4 years since we last had a couple of webinars. We're going to begin with Mike Rayo talking and introducing this particular series, and then we have two papers, and we'll introduce those papers after Mike has given his introduction. Mike, over to you.
Good morning, good afternoon, good evening, everybody. My name is Mike Rayo. I am the Secretary of the Resilience Engineering Association. And like Anthony said, we're really excited to get this webinar series up and off the ground. It's been a while. We're back. And this webinar series is actually a nod to how international we are and how hard it is for us to get together every 2 years in one place. So there were a lot of really great papers, a lot of really great presentation proposals, but they couldn't quite make it to Canela, Brazil, a month and a half ago. So we're going to start this series bringing you some of those papers that were accepted to be in the symposium, but just couldn't make it across the miles. Um, Now, I'm not going to introduce our presenters, but the other hat that I wear is the director of the Cognitive Systems Engineering Laboratory, the oldest and largest cognitive systems engineering laboratory, and also one of the founders of cognitive systems engineering, as well as, perhaps more appropriately to this conversation, resilience engineering, due to our founder and former director, Dr. David Woods. Just really excited to have you all here. I'm going to put links in the chat for both the REA webinar series. You'll see that this one's on there. Our next one is coming up likely in January. And I'm also going to put we have a new series associated with our resilience engineering and proactive safety initiative within my lab. We have a webinar series as well. I'll put that link in the chat as well. So a lot of stuff coming up in the future. So I will stop talking, which everybody who knows me knows that's very difficult, and I will kick it back over to Anthony. Thanks, Anthony.
Anthony, you're on mute.
One more time. Well, good afternoon, everyone. My name is Anthony Smoker. And with Sudeep Hegdar and Maria Carolero, we three are working as the REA webinars team. And this is being the first of our webinars in a new series, 25 and 26. So I'll be hosting the session today. Sudeep will be moderating the two papers. We'd like to welcome everyone here. So thank you for joining us today. The objective of the webinar, as Mike says, is to pick up some of the papers that were not able to be presented in Brazil and just to make them more available for everybody to get a flavor of what was in the conference, and more importantly, to showcase these papers that were accepted and were not able to be given. There's some logistics we'd like you to consider, please. We will be recording this, and in Europe, the GDPR rules will apply. So we need to be mindful of that. We would like you, please, to switch microphones off and to turn the video off so we get the better chance of optimizing the audio quality and focus on the participants themselves. In the case the webinar gets hacked, which is a possibility, we will record the session and do it separately another time to upload it. Questions and answers are really important to us, and we won't be using verbal. We're going to be using a Q&A element that's in Zoom. So I hope if everybody can see that, it should be open. If not, let us know. We'll try and get Mike to unravel it. But please post questions. We think it's probably better to put your questions in the component when they occur to you during the presentations. And then we'll take a couple of questions after each presentation has been given, and then we'll have some further time at the end of the session to have other question and answers, but also maybe some discussions as well. See how it goes. So please feel free to pose questions during the talk. Use the Q&A functionality, and we will try to get through them all afterwards. It's an informal talk. This is very informal. So please, all questions, there are no silly questions in these considerations when we're discussing this. So we should go over to Sudeep then, Sudeep, to introduce the first paper.
Okay. Right. Hello, everyone. I have the honor of introducing speakers today. So The first talk will be given by Marisa Bigelow and Leia Lyden, both from Mile 2. Marisa Bigelow leads multidisciplinary teams as a senior cognitive systems engineer specializing in resilience engineering. She has presented internationally on distributed incident response in DevOps teams and has over 7 years of experience designing decision support aids for human machine systems in various domains, including defense intelligence, medical, and autonomous aircraft systems. Uh, Along with her would be Leia Lyden, who graduated from The Ohio State University with a master's in industrial and systems engineering, with a focus in cognitive systems engineering. She has worked for over 4 years as a cognitive systems engineer to help design decision support aids for human machine teams and data gathering platforms in domains such as the medical field, research labs, and defense intelligence. So I will let speakers introduce their talk and hand it over to them.
Thank you so much for the introduction. Oh, I realize I have to request sharing, so please, Mike, grant me the access for that. Thank you very much. All right, confirming. Can everyone see my slides?
Yes, we can see them.
All right, thank you so much. So today we're going to be talking about a particular application of resilience engineering for the defense domain. So whether you all are familiar with it or not, we're going to go through a particular use case that is plaguing the U.S. Department of Defense, so specifically around aerial refueling. So to baseline, we're talking about for the current state of aerial refueling, we're thinking about several different roles in this space. We have fighters who are engaging with enemies on the front line, and we have tankers that are providing refueling capabilities to them. In addition, we have air battle managers, ABMs, who are coordinating the refueling events between the fighters and the tankers. They also have to coordinate with more blunt end command and control, C2. Now, the challenges in the space are multiple here. Primarily, the tankers themselves have to be far enough away to stay safe during these missions that are occurring in this airspace. However, since they're so far away, fighters have to frequently go back and forth to be able to refuel and be able to replan accordingly. Because there's many different times where anomalies start to occur and they have to change their initial plans. The challenge is that between the air battle managers and C2 that are coordinating those replans, it can take anywhere between 15, even 20 minutes at most to be able to push out a new course of action for them to replan. All the while, fighters are, of course, burning gas and time not engaging in the fight. So we want to be able to apply resilience engineering to change this current state, to make it more adaptive and be able to enable greater anticipatory look ahead. This envisioned state really relies on design solutions and algorithmic support to be able to create a better flow for this workflow. Specifically, we want to reduce that course of action generation turnaround time. If we make it faster and we push down initiative, so then the fighters at the front line can make changes on the fly, we can distribute the authority in a way that can better anticipate when bottlenecks will occur. The goal here is to make sure that the tankers can coordinate directly with receivers. If they have to move up, if they have to change where they're going to refuel, they can do that without needing the full C2 support. So they can coordinate faster and adapt when necessary to changing conditions. Now I'll hand off to Leah to go into a little bit more detail about what this process looks like.
Thank you, Marissa. So given the current technology of the battle space, as previously mentioned, pre-mission planning is conducted in a way that errs on the side of caution, right? And so that means that the tankers will be pushed further away from the fight in order to maintain their safety. In addition to that, as mentioned previously, the fighters will have to travel longer distances in order to get there. However, whenever an anomalous event occurs that exceeds the pre-mission planning expectations and assumptions, a fighter will then have to request for a new course of action. When this happens, air battle managers must communicate with everybody involved, and sometimes even the fighter reaches out to the tanker, as well as the air battle manager reaches out to the tanker and other parties involved in order to understand their current situation and perspective. As the air battle manager is replanning and evaluating all of these different perspectives in the current battle space, before they can distribute the new course of action, they must get approval by command and control, which can take up to, like as mentioned, 10 to 15 minutes or more. And while the fighters are waiting for this new course of action, they are burning fuel, which could be negatively impacted by their plan, even when they do receive a new course of action. So once the new course of action is approved by the command and control, it will then be pushed out to other entities involved. In this current space, it produces a centralized approach to decision making. Due to the fact that COAs must be approved by command and control prior to distribution, it produces the need for manual communication and coordination when anomalies arise, which can delay the response time during replanning, as mentioned previously. The need for manual communication and coordination is required due to the limited situation awareness of the battle space, which reduces the ability to effectively adapt to dynamic and evolving conditions. During these replanning events, the ability to maneuver resources around is also a challenge due to the fact that refueling resources that are present in the sky during each mission are the only resources available at the time. Therefore, given previously stated challenges, resource adaptive capacity is also limited, and if not replanned in a timely and effective manner, fighters will have to be sent home earlier than originally planned, which is the opposite of one of their goals. They want to be able to stay in the fight as long as possible. So this results in higher risks of decomposition, working at cross purposes, and getting stuck in outdated models of the fast-paced, high-tempo air battle space. A potential algorithmic solution can help improve the current workflow by greatly reducing the turnaround time it takes to generate a new course of action. And the biggest difference here is that there will be minimal communications needed for this new course of action generation. As you can see, the first 3 stages of the workflow will still remain the same. However, the last 2 stages is where this potential solution will be able to greatly improve and decrease the decision making and replanning process. Instead of waiting on command and control to approve the final course of action, the COA will be generated given the technology and be approved by the air battle manager with oversight from the tanker, and then pushed out to all parties involved much quicker than previously stated in the current workflow. This potential solution will provide immediate value to the battle space. And by pushing down the initiative to the receivers and tankers, it would transform their roles and responsibilities and provide greater visibility of data across roles, which will allow for the ability to quickly detect when circumstances change and anomalies arise, which will also provide a greater ability to adapt when disruptions occur. And the potential technology will also be able to provide the ability to have rapid refueling decision support to assess options on the fly. This will result in faster decision cycles, increased time maintained in the fight due to fighters being able to, due to tankers being able to move closer to the fight, and increased fuel efficiency.
So taking a step back, thinking about the resilience concepts at play here, obviously there's high cost of coordination. As Leia said, if we have to replan, there has to be currently purely manual communications between all parties involved. So to combat this, we would have to increase the availability of data, particularly shown in context, to provide greater visibility for both current and future plans, as well as the impacts of what those changes to those plans would look like. Obviously, we would have to broaden out that local awareness. So ABMs are not just limited to being able to have direct communications and limited scope of their influence. They would have to be able to have faster anticipatory course of action generation. And the key here is that there will still be reactive planning, of course, to anomalies that occur in this very fast-paced environment, but we also want to provide more proactive planning as well to anticipate when there are bottlenecks that will likely occur. We also want to have, of course, combat these slow and stale models. Everything is moving so quickly that plans quickly get outpaced by the world. So by pushing down initiative to those frontline pilots who are the closest to the fight, they can be able to provide that information to back up to APMs, all the way up to C2 to prevent bottlenecks and directly replan with the tankers that they need to refuel with. And at a high level, we want to be able to help with the risk of decompensation. These are tight margins that we have, not necessarily a lot of refueling that's capable to be done over and over again. So by broadening out awareness across these different echelons, C2 at the blunt end can be able to see across battle spaces better and be able to shift around resources proactively across those different areas and have really a transformed battle space. Of course, there are still challenges that remain, even as we've identified some areas that we can try and help improve the process. When we talk about the defense domain, we are talking about adversaries. And of course, as we try to be more adaptive, as our systems and our technologies grow, our enemies also are highly adaptive. They can even deny our comm systems, provide jammers that block our sensors. So there are ways that we have to anticipate that we have to be even more adaptive in our technologies and our solutions. Of course, this leads into the other caveat that we're always resource and viewpoint limited. We have complex array of different sensors and comms relays that are available to us, but we are reliant on those. We are reliant on being able to have direct communications and viewpoint into the world. So we need to have functionally diverse contingencies to be able to combat any sort of challenges that we might face if any of those sensors and comms go down. To summarize, we do see a clear path forward for the human-machine team in this space. Managing the cost of coordinations will help bring around faster turnaround time, especially with algorithmic support, to be able to replan faster from the time when we identify a need to replan, whether it's reactively or proactively, all the way to being able to push out that course of action and being able to push down greater initiative with more data and context so they can see at the front line exactly what's going on. So they can hopefully be able to gracefully extend the system, be able to look ahead and adapt to upcoming bottlenecks, perhaps when they're burning hot, trying to do maneuvers and burning fuel faster, or when they're anticipating needing to go dark, turning off their comm systems and relying on their ability to adapt and follow the plan that they have currently. Of course, this is an evolving air picture. The common operating picture is very dynamic, especially with dynamic adversaries in the space. So by showing those resources in context, they can be able to shift them around dynamically to fill in gaps as they appear. And have cross-scale collaboration across multiple roles, multiple echelons, because we know goal conflicts are inevitable. So they need to be able to see, especially with automated code generation support, they need to be able to resolve those conflicts, look ahead, and to accelerate and augment expertise. Thank you for your time, and please post any questions in the chat.
Thank you very much indeed, Marisa. No questions in the chat. I wonder if you could go back to your presentation to the penultimate slide, please, because there's a question I'd like to ask you about. the functionally diverse element. The one before. Yeah, the last thing, maybe difficult to have functionally diverse contingencies percent breakdowns. I wonder if you could elaborate, if at all, on what you mean by that, by functionally diverse.
Well, I've seen cases in the past, such as Ariane 5 rocket is probably a great example, where if you have functionally similar systems, let's say an identical backup to a system, you run into the same problem. If a problem occurs with one system, it can easily cascade to the second system because it's completely identical. So functionally diverse is thinking about it from a different perspective. They're not identical contingencies. They achieve the same function. Like, let's say, for instance, I'm trying to look at a particular area with a camera. I might have one particular type of camera. Maybe it's uh, a typical electromagnetic spectrum camera that you might have in normal operations. Then I might also have an IR camera as well, having multiple different types of cameras. I'm still able to see the world, but I'm looking at from different perspectives. And they fail in different ways. So I can be able to at least have a better perspective around the boundaries of those different systems. So I'm functionally providing more capability in ways that I'm trying to anticipate they won't break down the same way. Which, of course, things can still happen, but it's trying to diversify some of those viewpoints in a way that makes it more resilient to various different breakdowns or intermittent errors that might occur.
Okay, thank you. That's very clear. Thank you. You also made the point earlier about the need to find adaptive capacity in different ways. So presumably functionality diverse can lead to a different path for adaptiveness.
Yes, and it has to be a critical way that we achieve that because we can't have it the exact same across the board. Then you start seeing those cascading failures, decompensation happening. We have to be able to break that chain. And ideally, you break it during the design process of the system, far beyond trying to rely, of course, in real-time operations to make up for those problems.
Great, thank you. I've got two questions in the Q&A now from Kalle Van Bauer. Good morning. Where do you all see the largest impact of this approach to decision-making COA generation? Would you like to comment on that, Marisa or Leia?
That's a great question. So, in terms of decision making, I mean, one of the biggest areas, I'll move to this slide as well, is really the data and context. Like in a space that's so diverse, so dynamic, it's very challenging to make sure that everyone has a clear picture of what is happening at the time. In terms of decision making, I think that is one of the biggest areas that we can really help is providing design systems that show the data in context. For instance, showing what the current plan is. And when you're evaluating for potentially new course of action options, showing what those impacts look like. Let's say it's on a map. You can see where my tanker is currently, where my fuel is relative to that, versus what's my other option. How likely am I to be able to get there with a sufficient amount of fuel? So that, to me at least, is one major element of showing the involving the ability for replanning in the space.
Thank you, Marissa. And Caleb, please feel free to come back with a follow-up question if you would like to. A question from Douglas Owen. Would a fighter crew requesting a specific COA, e.g. priority refueling, to exploit an opportunity in line with the overall mission goal, how would that play out with the proposed approach? Marissa or Leia, would you have a view?
I think
Mike, you're
that's
going to.
I think that's a great point because we're not just talking about, maybe the plan is slipping where things are being delayed. We're also talking about taking opportunities where they see them. This actually occurs quite a bit, especially on the tactical level, where maybe that a shift in objectives happens, and you want to be able to take advantage of the fact that I need to burn hot right now, is how they describe it. I need to burn fuel very quickly to be able to keep pace with my adversary. And so that is a time that they want to be able to uh, request a new course of action proactively to say, hey, I'm going to need more fuel because I am taking advantage of the situation. And that's a great thing, but it does, of course, provide strain on some of the other tankers providing those resources. They might need to be shifted around to make sure that we have coverage across the board.
Thank you. I think it's a really very interesting question around how we create opportunities from resilient performance. And that provides a nice counterpoint to some of the other sides. Mike, do you want to say anything, or you content with Marissa's answer the question?
I have lots of questions that I could ask, but I'll wait. It seems I want to make sure that the other presenters have enough time, and then we can get into it. Thanks.
Great. Okay, great. Thank you very much, Marisa. Thank you, Leia. Very articulate presentation. And thank you. And Sudeep, if you could introduce the next presentation, please.
All right. So the next presentation is also by Marisa, but this time with Kati Walker, who graduated from The Ohio State University, focusing on resilience engineering and accident analysis. She has worked for 5 years in a cognitive systems engineering role in fields such as human AI teaming and autonomous vehicle control. So over to Kati and Marisa.
All right, thank you very much. So I have the pleasure of introducing this one, but I'll be handing it off shortly to Kati. So today we'll be talking about hardening human-machine teams against misinformation and manipulation. When we talk about hardening here, this is not just a matter of making this, a more robust type system. We're also thinking, of course, from resilience perspective, how to make some of these technologies that are so prevalent and so prevalent right now, specifically AI technologies, how do we make this a better team player in the space? As I said before, AI is incredibly prevalent right now. And we've been conducting some research into how to evaluate these human-machine teams more effectively, especially when it comes to misinformation, because that is a core challenge when we think about these technologies being used for everyday purposes. The enthusiasm for this technology is very much rampant right now. We have technologies like generative AI, large language models that are being adopted widespread across the industry. However, they have truly outpaced our understanding of the associated risks of using this technology, particularly for the impacts of the human users, are not fully understood. Of course, we're applying the same types of resilience engineering principles we've seen for years on automation here, but the impact and the scale of this technology really has changed and evolved over time. One of the main things that we're talking about here is that for these types of technologies, like large language models, they are challenging because they are wrong, strong, and silent. They're not just brittle and literal-minded machines. These types of technologies feel like you're talking to a person. However, it's very much a person that might have a wrong view of the world. They might be very strong in their opinion, might seem very confident, operating at high speeds, and sometimes with very high authority. And they can be very silent. They don't necessarily communicate their limitations, uncertainties, or biases to the human user. And so this misinformation that is very easy to generate can be incredibly hard to spot. And of course, the consequences of relying on this type of misinformation can be severe or even life-threatening.
So there are a number of ways that LLMs can generate misinformation, and our research focused on 3 specific types. The first one is biased responses, where biased training data sets can cause the LLM to favor certain ideas or perspectives when it generates outputs. And again, like Marissa said, this can be very, very difficult to see because the training data sets can be enormous. You can't go through all of them and make sure that the model is only training on things that you would like it to train on. So this particular study was conducted recently and published in Nature, and they tested 5 different LLMs to determine the prejudice they created against speakers of African American English versus speakers of standardized American English. And the models, all 5 of them, generated extremely strong stereotypes, extremely negative associations with speakers of African American English, to the point where in a simulated experiment where it was asked to judge defendants in first-degree murder cases, it sentenced speakers of African American English to the death sentence far more than it did speakers of standardized American English. You can see where unintentional bias can cause life-changing consequences. Hallucinations are where the model presents false information as fact. And hallucinations are a problem for any large language model. And as far as we can tell, they're going to be very, very difficult to eliminate. So this is something you should expect going forward in the future. Deloitte helpfully presented us with a couple of recent examples. They created reports for the Canadian government and the Australian government that contained a number of non-existent academic references. And unfortunately for them, some unhelpful academics pointed out that the papers not only didn't exist, but they had never worked with the people that it had said they had worked with. So this is a clear example of the problems with faster, better, and cheaper. They lost a lot of money on this. For the Australian government, they had to refund at least $400,000. And the report for the Canadian government cost about $1.6 million, and they are also pursuing a refund. So you can see at this point, it may have been better or cheaper to hire some interns. And it is not advancing. There we go. The last thing we took a look at was deliberate poisoning, which is where bad actors force the LLM to behave in specific ways. So there are a couple of different ways you can attack large language models, the most prevalent of which is intercepting the prompts being given to the large language model and changing them in some fundamental way. When this happens, it can cause a couple of different things designed by the bad actor. The bad actor may cause the LLM to provide biased information. They may cause hallucinations where the answers are subtly or very wrong, and they may cause the LLM to refuse to answer at all. Now, this particular picture is from a different type of attack. This particular one is called Bad Rag, and it's interesting because they attack the document corpus itself. So instead of manipulating the system prompt, they take a look at injecting a document with a poison prompt that's hidden somewhere in the database, and it is picked up as relevant and then executes that prompt. So right now, there are fingerprints of misinformation out there that we are totally relying on to catch when the LLM is doing something we don't expect it to do. So the image to the left is an obvious one from the problematic paper screener. And in this, the LLM's alignment mechanisms are causing it to refuse to provide advice about a specific medical condition. So you can see in there that it completely refuses. It says it's an AI model, and it's very obvious now that this paper has been generated partially or fully by AI. On the table to the right, the problematic paper screener uses tortured phrases as one of the ways it identifies AI written papers. And tortured phrases are legitimate academic concepts that the LLM has tried to disguise LLM writing, so it is using synonyms in a way that makes the academic concept nonsensical. So clearly my favorite one here is bosom peril for breast cancer, although message just for text only is good too. And these are very obvious. Unfortunately, some of these obvious signals are starting to go away as LLM technologies advance. So you can see on the image to the left, when we looked at AI-generated images, we used to be able to count fingers. We used to be able to look for strange textures or shadows in the wrong place. Those are starting to go away. AI images are starting to be much harder to spot. And even with the problematic paper screener, we can see that in 2025, and this is up to date, they have found far fewer papers with problematic references than they did in the past 5 years. And this is just a way to show that the development of LLMs is starting to hide the cues that we could once rely on to look at whether or not the LLM was misbehaving in some fundamental way. So this causes a lot of interesting things for us as resilience practitioners. And one of those things is that the information that's out there is massive. The training data set is massive. The amount of references the LLM is pulling in is massive. And the LLM is not designed to be understood by humans. So the United States government recently asked Anthropic to turn over the model weights for its Claude system. They refused to provide the model weights or the training data, but honestly, what would you have done with it? It's not designed to be understood by humans. It's a marvel of modern statistics that just doesn't make sense to anyone but the model itself. So our challenge here is to help people understand information that they cannot directly interact with. So if we can't take a look at the information, if we can't just comb through it and look for problems, what do we do to find when the model is misbehaving? So there's a couple of tests out there right now for mitigating misinformation and understanding when the model is doing something wrong. And for biased responses and hallucinations, these two are pretty similar. And this is more of a concept than a tool itself, which is great because as resilience practitioners, we know that designing tools to catch tools will suddenly become slow and stale one day. So this is a method of show me your work, show me what you're thinking. Where are you pulling data from? Why? What types of data sources are you using to assemble that answer from? And you can think of Google's AI search response. So once upon a time, it told a user that they should get minerals by eating very small rocks. And if you took a look at where the model got that information from, you would see that it's a Reddit post that's mostly supposed to be a joke. So if we can surface those sources, if we can surface how the model is putting things together to come up with an answer, we can help people understand where misinformation is coming from and find subtle cues in the data, find subtle cues in the answers that the model is doing something wrong. For deliberate poisoning, there are a couple of statistical tests that are out there right now. These are going to change as AI models improve, but some of the concepts stay the same. So for example, the MAUVE test is an update to a perplexity score test, but what they're both thinking about is the linguistic and grammatical diversity of the answer as compared to human text, and also the just probability that that makes any sense, the answer that is making any sense. Oops, skipped a slide. So the first thing we want to take a look at is how do we make AI a team player, like Marisa mentioned at the beginning of the talk. So we really want to see how observability, predictability, and directability of the joint human-machine system can be managed, particularly with the AI. So right now, AI systems have limited ability to show their reasoning and often don't show their training data at all. So when we come up with that, why are you thinking that way? What data are you pulling from? What data are you not pulling from? That can give the user more insight into what the model is doing. Right now, models have low predictability. They have an inherently stochastic behavior where if you ask the same model the same question twice, it will not give you the same answer twice. It may be slightly different or it may be completely different. And this is worse even across different types of models. So if you can examine it long term, you can establish a baseline expectation of what a model answer, a good answer might look like. Unfortunately, that only works if you have worked with the model a long time and you're able to capture some of those cues. So we'll get into that a little bit later. What happens if you are only working with the model in one-off or limited situations? There's also limited directability of the model. Right now, you can see on certain models, they'll ask you for a thumbs up and a thumbs down. You can indicate whether the information was correct. You can indicate maybe whether you liked the format of the answer, but it's very difficult to redirect it to support your goals as the human user. And that is someplace that we're really going to have to support as resilience practitioners moving forward. Other thing we were thinking about is reframing. So it is very difficult to get people to break away from their initial frame because these models have high authority. They're talking like a human that knows what they're doing. But we want to support the user in using incoming information to re-explain what might be happening with the model. And there's a pretty good recent example of this where a company was using AI to screen their resumes and they realized they weren't getting a lot of good candidates. And initially they explained it away. Well, our requirements are kind of strict. We're a good company. Maybe we're just not getting a lot of good candidates. But eventually the CEO started to notice inconsistencies and wonder if this was plausible. We're getting a lot of applicants. There are a lot of job seekers out there. Why is there no one out there meeting our requirements? So he decided to take his own resume and put it into the AI system and found a total anomaly that even his resume wouldn't have gotten him hired at his company. And so that broke the frame, and they realized that the AI model was not allowing any resumes through, whether they were qualified or not. And of course, we couldn't end a resilience presentation without giving a shout out to the joint activity testing. So what we want to do is monitor for those brittle failures and help people calibrate for whether or not the model is a good fit for the condition that they're in. So right now, a lot of AI tasks force users into a vigilance role where the AI is making a decision. It's frequently correct, but occasionally it's very incorrect. And as you can see with some of the models on the left, that brings the performance of the entire joint cognitive system down. So if the AI model misbehaves in a large way, even if the nurse otherwise would have known what to do in this emergency situation, everything gets worse because of the high authority and the way that the model sounds. So instead, what can we do in order to show the users the strengths of the model, the weaknesses of the model, and especially where the model is getting its information from and how it's using that to assemble the answers. And in this particular study, it was with nurses in emergency and non-emergency situations interacting with an LLM that was supposed to help them with medical diagnosis. The nurse, after a understanding of how the LLM worked, really one of the most critical ways they changed their opinion is by understanding where the model was getting its information from. So where it was pulling information from, and critically where it wasn't pulling information from. So thing usually when I'm thinking about AI comes back to the idea of observability and directability specifically. So we want to help them understand these strengths and weakness. We want to show them where is the information coming from? How is it being used to assemble an answer? Even though these data sets are very large, even though the sources they pull from are numerous. And we also want to be able to direct them in a way that supports the goals of the human user, not the other way around, which is frequently where we are now. So thank you for your time, and let us know any questions.
Thank you very much indeed, Katie and Marisa. No questions in the Q&A section. Fascinating presentation, which gives more questions than answers, I think. I mean, the back of my mind where's the moral and ethical position in this. But I was most interested in that last slide where you talked about vigilance and AI. Yes, that first bullet point. And I recognize that as the automation paradox, where automation tools provide a level of accuracy, consistently accurate, and then suddenly there's something happens and it's not. And yet the human being somehow has to intervene in those situations. Is this a replication of Lisa Bainbridge's automation paradox?
I think that is a good comparison. So one of the things that we took a look at in this study was called slop squatting.
Ooh.
And the user is generating code. And instead of the user being in charge, the automation is generating the code. It usually does so correctly, but occasionally it generates or hallucinates a Python library that's not there. And the user is forced to either comb through it line by line, trying to find if the AI made a mistake, or they're very vulnerable to a situation in which a hacker knows that the LLM often makes that mistake, builds the Python model with a virus in it. So I can very much see that it comes back to automation that is infrequently making mistakes, but it's devastating when it does.
And in fact, the AI or the LLMs amplify that problem rather than the one that Bainbridge's world thought of, perhaps.
Yeah, does it faster. It does it with higher authority and sometimes. So
Yeah.
And actually, there's an interesting point here on the slide as well about boundaries. So, because we talked about it before, that these models feel like you're talking to a person. So you start to think, is this capable of, I don't know, maybe picking out my clothes for tomorrow? But it has no concept of what my closet looks like, what clothes are even the options for it. It only knows papers from a literature database. Those are the kinds of questions where it might not be obvious exactly what the boundaries are of, what its capabilities are, if I wanted to be able to extend beyond what it currently is capable of. So that's another area where part of
Yes.
that the comparison that you made before really comes into play. Because it's hard to know, is this something that I can get a reliable answer for when it was reliable in so many other cases, but not in the particular one that I'm trying to ask it?
Yeah. Thank you. Thank you, Marissa. There's one question in the Q&A from Douglas Owen. Mike, do you want to take that question live?
I can certainly. I just wanted to, I wanted to encourage you to take that question or somebody to take that question.
Okay, right. Yeah. Okay, thanks. So the question in the Q&A then, Marisa and Katie, is it right to assume that the goal of the LLM developer is for the tool to be helpful, or just for the tool to be used undetected? Is this a tension between the LLM developers and the end user? Brilliant question. So over to you, Marisa and Katie, for a brilliant answer.
That's a tough one. So definitely. Sometimes the goal is for it to fade in the background, and they always intend for it to be useful and helpful in some way. But the LLM doesn't know what it doesn't know, and the person doesn't know what they don't know. So in one-off situations, especially where you're not able to observe trends over time, for me, that becomes a problem for hallucinations or biased answers when there's just not enough data to realize the model boundaries. Marisa?
And I concur with you, Katie, and I think especially it does depend on the application. You see numerous sites, especially in like the commercial space, for instance, where you might have a chat bot that might be able to help you specifically. They try to make it, in some cases, very obvious that this is algorithm that is supporting you versus a human that might be answering your question. Of course, I'm always of supporting trying to build in more transparency, making it more obvious. So at the very least, you can start that calibration process without any deception in the work. So I'm always a fan of trying to make sure that's very visible. But either way, it does make it difficult when you don't understand the boundaries of its capabilities and where it's pulling that data from.
Boundaries are really quite intriguing, I think, and particularly when safety critical systems. So one, Gwilda Grotta from ETH Zurich read a paper earlier this year with somebody and made the point that LLMs recreate themselves. Exactly what you were saying, Katie. So in that context, how can we use these in human autonomy teaming in safety critical tasks? What are the implications of your research for the application of LLMs in safety critical tasks?
We have done a little bit of research with Clemson University, and I can't get too much into it because the paper is in review. But one of my favorite findings from it was that when people were presented with a biased answer, they didn't necessarily think it was incorrect. If they could find justification for that information anywhere, they tended to believe that the LLM was helping them. So in safety critical settings, this gets very dangerous because if they can explain away or they can justify to themselves why the LLM is working in that way, and there is no information to help them notice that the LLM might not be capable of handling this situation, it's getting near its performance, the edges of its performance envelope, then it can be very difficult for them to break away from the feeling that the LLM is correct. So there has to be a lot of observability in safety critical systems of, and this is, LLMs are not good at this right now, confidence. How confident am I in this answer? How do I have the right information to give you an answer in this context? And that will be something that as resilience practitioners, we've really got to steer people in the right direction because people aren't going there right now.
That's a very radical application of resilience engineering, actually, in the future.
Mm-hmm.
It comes down to the level of the practitioner to be able to work in those ways.
Mm-hmm. And for the system design itself to support it, of course, right? Yeah. One of the most dangerous aspects, I would think, is drift, actually, that these systems, like Katie said before, they're stochastic. They're not deterministic. They will not give you the same answer every single time. But more than that, they also change over time, and
Yeah.
their performance can drift farther and farther from the expected outcomes as time goes on. So that can be very dangerous when you're relying on that for any sort of safety application.
Brilliant. Thank you very much indeed. Well, we're approaching the end of our time, so if there are no other questions, Mike's got a comment in the Q&A, the questions. The classic issue and a bigger than AI. What is the condition of the basic compact? Are we all really on the same team here? Between solution developers and the target system of use is a fabulous comment. So thank you. Yeah, I think it is discussions like these that bring open some of these particular dimensions. And I particularly like the point about boundaries. How can we even identify the boundaries? So thank you very much. So if there's nothing else, then I'd like to say then we'll close this now. We're hoping to have another seminar with 3 more papers from the symposium in January, but it may slip to February. We hope to have at least one of the presentations and papers uploaded in the REA LinkedIn site, and will there be a YouTube channel we have for the presentation. So thank you very much indeed to Katie, Marisa, and Leia for 2 really articulate presentations, thought-provoking, and plenty of scope for further webinars, I think, from this. Thank you very much indeed. And with that, thank you everybody. Have a happy Christmas, and we'll see you at the next REA webinar. Thank you.
Thank you to everyone.
Thank you. Bye.